Diving deep into AdaBoostRegressor, a detailed explanation. The AdaBoostRegressor, a powerful ensemble learning algorithm in scikit-learn, is a fascinating blend of simplicity and effectiveness. Let's dissect its workings and explore its capabilities. 1. The core principle: adaptive boosting. AdaBoost, short for adaptive boosting, is a method algorithm, meaning it leverages other learning algorithms, often called weak learners, to build a strong, robust prediction model. It works by iteratively training a series of weak learners, each focusing on misclassified instances from the previous iteration. The key to its success lies in adaptively weighing the training data, giving more emphasis to samples that were poorly predicted by previous learners. This gradual refinement allows AdaBoost to boost its overall performance. 2. Building the ensemble, a step-by-step guide. Initialization. The data is assigned equal weights initially. The initial model, a weak learner e.g., decision tree, is trained. Iterative learning. For each iteration, the model's predictions are obtained. Sample weights are adjusted. Misclassified samples get increased weights, promoting their focus in the next iteration. A new weak learner is trained with the updated weights. Final prediction. The predictions from all trained weak learners are combined, weighted by their individual performance. The final prediction is a weighted average of these individual predictions. 3. Key components of AdaBoostRegressor. Weak learners. The most common choice for weak learners in regression is decision trees, especially decision stump trees with just one split. This simplicity enables AdaBoost to capture complex relationships in the data. Learning rate. This parameter controls the step size for updating sample weights. A smaller learning rate leads to more gradual adjustments, potentially resulting in smoother convergence. Number of estimators. This defines the number of weak learners iterations in the ensemble. More estimators usually lead to higher accuracy but can also result in overfitting if not carefully managed. 4. Strengths and weaknesses. Advantages. Robustness. Less susceptible to outliers and noisy data compared to single models. Versatility. Can handle various types of data, including both numerical and categorical features. High accuracy. Often achieves high accuracy, particularly when dealing with complex datasets. Disadvantages. Potential overfitting. Requires careful tuning of the number of estimators and learning rate to avoid overfitting. Computational cost. Can be computationally expensive for large datasets, especially with a high number of estimators. Black box nature. The model's inner workings can be difficult to interpret, making it harder to explain predictions. 5. Practical considerations. Data preprocessing. Standard data preprocessing steps. Normalization, scaling, handling missing values are crucial for optimal performance. Hyperparameter tuning. Experimenting with different values of the learning rate and number of estimators is essential to find the best model configuration for your specific data. Cross-validation. Employ cross-validation techniques to evaluate the model's performance and prevent overfitting. 6. Example in Python. Python. From sklearn, ensemble import AdaBoostRegressor. From sklearn, tree import decision tree regressor. From sklearn, model selection import train test split. Grid search CV. Load your dataset. X, Y. Load data, split into training and testing sets. Xtrain, Xtest, Ytrain, Ytest. Train test split X, Y. Test size 0.2. Random state 42. Define the base estimator decision stump. Base estimator decision tree regressor. Max depth 1. Create the AdaBoostRegressor. Regressor AdaBoostRegress or base estimator. Base estimator Nestimators 100. Learning rate 0.1. Random state 42. Tune hyperparameters using grid search CV. Paramgrid nestimators 50. 100. 200. Learning rate 0.01. 0.1. 0.5. Grid search CV regressor. Paramgrid. CV5. Grid search. Fit X-train. Y-train. Evaluate the best model on the test set. Best regressor grid search. Best estimator. YPRED best regressor. Predict X-test. Calculate performance metrics e.g. R2 score. From sklearn, metrics import R2 score. R2 score test. YPRED. Print FR2 score R2. In summary, AdaBoostRegressor is a powerful ensemble learning tool capable of achieving high accuracy in regression tasks. By understanding its workings, its strengths and limitations, and implementing best practices, you can effectively leverage this algorithm for a wide range of predictive modeling challenges.